The overall goal of the following experiment is to demonstrate the simplicity of fuel and observe the generation of red photons due to radiative excitation emission events. This is achieved by combining bioluminescent bacteria and luminescent nanoparticles for the production of fuel. Next, a bioluminescence plate reader is used to observe the resulting red photons that arise from fuel. Results are obtained that show a substantial quantity of red photons can be produced when the bioluminescent bacteria and quantum dots are maintained within the same solution based on the observed increase in red photon flux.
The implications of this technique extend towards questioning the paradigm of bioluminescence resonance energy transfer, or BRET, as is often reported in the literature.
Starting from individual colonies on standard culture plates, start overnight cultures of luminescent bacteria. Here, Vibrio fischeri were used. The day of experimentation, initiate fresh subcultures. Allow them to progress until an optical density, or OD, at 600 nanometers of 1 to 1.5 is achieved. Use bacteria in similar growth states in which they produce intense signals to achieve comparable results. Combine aliquots of 100 microliters from each with either 5 microliters of the fluorescent probe QD70.